Okay, we're going to learn how to solve absolute value inequalities. And we have two main inequalities. We have the case that is less than 3, and we have the case that is greater than 3. So we're going to look at the numbers that we could plug into both and what the graph looks like. So if I were to put, say I were to put -4 in here, and I had the absolute value of -4, well, absolute value of -4 is equal to 4. Is 4 less than 3? No, it's not. So -4 does not work. Well, what about -2? Does -2 work? Is the absolute value of -2 is equal to 2? Is 2 less than 3? Yes, it is. Well, what about 0? Is the absolute value of 0 less than 3? Well, the absolute value of 0 is 0. Is 0 less than 3? Yes. What about 2.5? The absolute value of 2.5 is 2.5. 2.5 is less than 3, so that works. So basically, all of these numbers inside of here, except for, does -3 work? The absolute value of -3 is 3. Is 3 less than 3? No, it's not. So it's all the way up to, but not including, 3. So we know that x is going to fall between -3 and 3. So we're going to have an open circle on 3. It's going to come all the way over to an open circle on -3. It is x is greater than -3, and, so this is an and problem. Use a special color here to set it up. This is an and problem. If you and maybe you go with your grandmother to the grocery store and you ask for 2 items that are less than $3, she may say you can have one and the other. Now let's look at the greater than. If it is greater than 3, let's add a couple other numbers in here. Let's start with -4. The absolute value of -4 is equal to 4. Is 4 greater than 3? Yeah, yes it is. What about 0? Is 0, the absolute value of 0 greater than 3? Is 0 greater than 3? No, it isn't. What about -3? See, or let's go with something a little bit bigger than that. The absolute value of -2.5 is 2.5. Is 2.5 greater than 3? No, it isn't. Not there either. What about -3.1? Well, absolute value of -3.1 is 3.1, and that's greater than. So it's not equal to 3, but so we're in open circles, and it's anything that is on this side or anything that is on this side. So a greater than situation is always an or. An and versus an or. So let's look at an example. You cannot make the determination if it's an and or an or, so wait to determine if it is an and problem or problem until boogies are gone. Now I use the word boogies because it helps you remember and you can kind of visualize what that'll look like. So our boogies in this situation is going to be that -2 and the 3. So the first thing to leave would be the -2, so we're going to add 2, and then we have 3. Absolute value of r minus 8 is less than or equal to 3. And so then we are going to divide by 3. I divided by a positive, so I don't flip the inequality. So I have r minus 8 is less than or equal to 1. Now at this point, boogies are gone. It's less than. I know it's an and problem. So we're going to go ahead and split it into 2 cases. We have r minus 8 is less than or equal to 1. So you keep the exact same thing. And, make sure you write your and in there. R minus 8 is greater than or equal to negative 1. So we're going to flip the sign. And we're going to take the opposite of that answer. So now we're going to go ahead and solve those two little pieces. Add 8. So R is less than or equal to 9. Add 8. And so R is greater than or equal to 7. So now let's draw a graph of what that looks like. You always want to draw the graph. We're not going to use 0 there. Let's put 0 over here. And let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 7. There's 9. We want to, let's do this one in red. R is less than 7 or equal to, so it's going to go that direction. And this guy is R is greater than or equal to 7. And it's going to be everything that is in the middle is colored by both of those. So that works for your and. And so if we would do set builder, remember the X goes in the middle. It's less, less. You got to put the equal to signs because they're colored in. We have 9. We would have our 7. And then we got to throw in the such that sign. And your further basis. So that would be your set builder. So in an and situation, your arrows, it has to be the colors that cover both. So it needs to be both purple and red. If it's an or situation, it's going to be one or the other. And so wherever one of the colors is, so an or would be all numbers covered by one color or both. All it has to have is at least one color, and then it is good.